Good morning, good afternoon, and/or good evening. My name is Devin Deonda, and I will be walking us through the summary of steps for our communications project. Before any sort of problem solving or extrapolation of information can occur, one must find or identify the equation that we are going to be using in this situation, or that is the formula that we're going to be using in this situation. And then we must then proceed to find all of the respective values for said formula or equation. Again, these are going to be extracted from our situation that we find ourselves in. Once all the values have been pulled from our text and identified accordingly, that is to say, in the sense of knowing that a numerical value is time as opposed to temperature, and vice versa, one may then populate the aforementioned formula with its corresponding values. So, written out here, we have the formula, which in our case is Newton's law of cooling, and that says that temperature as a function of time is equal to our ambient temperature of whatever room or atmosphere we find ourselves in, added to the temperature of the ambient surrounding, subtracted from the temperature of our object, is multiplied by e raised to the power of negative t times k. K is the coefficient of decay in this equation. The values we were able to pull from our situation is that the ambient temperature of the room the body was found in was 70 degrees Fahrenheit. It was kept at a controlled 70 degrees Fahrenheit. The temperature of the body was 80 degrees, the temperature of our object. 80 is important because it was 80 degrees at time equals 0, or that is 7:30 p.m. when the body was discovered, which in our case is time equals 0. The equation substituted with the values is written out as temperature as a function of time is equal to 70 plus 80 minus 70 times e to the power of negative t k. What we are first trying to find is k. Our coefficient of decay enables us to find many other things, so that's our first priority. So if we algebraically work this equation out to restate it in terms of k, we get a resulting value of the natural log of 1/2 over negative 30. Noted here is that we're setting our equation to 75. The reason for setting it to 75 is because we know that after 30 minutes has elapsed, the body went from a temperature of 80 degrees to 75 degrees. So, and we can also see evidence of that as our 30 in this equation. So we substitute 75 here, put 30 where t is, and yeah, we algebraically solve our equation to restate it as such, and that's simply done by subtracting 70 from both sides, dividing out the resulting 10, using the natural log to take care of e, and then taking care of the negative and the k. Or I'm sorry, the negative and the t. So now when we have our k, of course this does equal a number, it's a decimal and it's not easy to state, so it's better left here. We can now have our equation whenever t is equal to 98.6. The reason for setting the equation to t equals 98.6 is, first, we're trying to find the temperature of the body at the time of death. We're assuming that the initial temperature of the body at the time of death is 98.6, which is the gold standard of average body temperature. So setting in 98.6 for temperature as a function of time, setting it equal to our equation, then gives us a value of our time elapsed from the moment the body was murdered to the time of discovery at 7:30 p.m. That value is a complex decimal of negative 45.4880, if you will. So we know that since time can't be a negative value, we work backwards from 7:30 p.m. to give us a time of death of 6:44 p.m. about, or 1800 hours, 44 minutes, 31 seconds, and 17 centiseconds about. That was simply done by taking our time elapsed and subtracting it from the time of discovery of the body, and the initial temperature of the body used in conjunction with our equation was able to give us the time of death. Of course, we have our campus, the time that the campus police arrived at 8 p.m., which again should be noted that is the same time that the body temperature was 75 degrees. So, summing everything up, we have k equaling roughly 0.023. Our time elapsed stated in terms of tenths of an hour, a interesting choice of unit. Time elapsed equaling about 0.8, and the time of death equaling that value. We have successfully completed and solved our murder mystery case, at least chronologically speaking, of course.